So our next topic is miscibility and partial miscible liquid. So first of all we must know that what is the miscibility. Miscibility means when you mix two liquids, that is two or more liquid like A, B or A, B plus C or A, B plus C, D and so on. They when they will mixed in a beaker, they will lose their identity and looks like a one single solution, one single liquid. So this is called miscibility. So there are some liquids are completely immiscible, some are miscible. If you have seen that if you will mix the water and kerosene or water or petrol, diesel, they will make separate layers, so they may be called as immiscible liquids. Whereas we have in your syllabus we have concern with the partially miscible liquids. So for example, if a small quantity of phenol is added to the water, that is H2O, it will at first dissolve completely. However, if the addition of phenol is continued, a stage is reached when no further dissolution takes place and two liquid layers separate out. One layer is saturated solution of phenol in water and other layer is saturated solution of water in phenol. So if you will take a container and you will mix two liquids, after a stage there are two layers like this layer and this layer, and one layer will have phenol in water, and other layer will have water in phenol type of liquid. So let me repeat, one layer is saturated solution of phenol in water and other layer is saturated solution of water in phenol. So the two layers in equilibrium are called conjugate solutions. The composition of both the layers depend upon the temperature and pressure. At constant temperature, the composition of each layer remains constant as long as two phases are in equilibrium. So as the temperature is increased, the mutual solubility of two layer increases till at a particular temperature the two layers become completely miscible and the solution has identical composition. The temperature at which two partially miscible liquids becomes completely miscible in all proportion is called critical solution temperature. So what is the critical solution temperature? That is CST. It is the critical solution temperature. So basically it's a temperature. So what kind of temperature? It is temperature at which two partially miscible liquids become completely miscible in all proportions and is called critical solution temperature. So to know the critical solution temperature, you first of all you must know the partially miscible liquid that I told you earlier from the example of phenol in water, that there are formed two layers in one is saturated layer of phenol in water and other layer is the water in phenol, and these are the conjugate solution, and these type of solutions are partially these are formed by the partially miscible liquids. So the composition of these both the layer depend upon the temperature and pressure, and if you will change the temperature, suppose increase temperature or decrease the temperature, there will be these partially miscible liquids become completely miscible in all proportion is called critical solution temperature. So or we may say that these two layers will become unidentical and there will be a single layer of phenol and mixture of phenol plus water. So this temperature at which these partially miscible liquids become completely miscible in all proportion, this temperature is called CST, that is critical solution temperature. So depending upon the nature of the liquids, the two liquid layer may become completely miscible at a temperature lower than the ordinary temperature or at a temperature higher than the ordinary temperature. So thus a system may have lower critical solution temperature or upper critical solution temperature. What does a lower? We may write it as lower critical solution temperature or upper critical solution temperature. Lower and upper means depending upon the it depends upon the nature of the liquids. The two liquid layer may become completely miscible at a temperature lower than the ordinary temperature or at a temperature higher than the ordinary temperature. Thus a system may have lower lower critical solution temperature or an upper critical solution temperature, or both. So three types of partially miscible liquid systems are as follows. First is the three type of partially miscible liquid systems are follows. Liquid pairs whose miscibility increases with temperature. In increase in temperature, the system having an upper critical solution temperature. So first type of the partially miscible liquids with upper critical solution temperature, that is that we have to increase the temperature to mix these partially miscible liquids. Second is liquid pairs whose miscibility decreases with increase in the temperature and having a lower critical solution temperature. Third is the liquid pairs whose miscibility increases as well as decreases with increase in the temperature. The system having both upper critical solution temperature and lower critical solution temperature. So further we will first of all discuss the systems having an upper critical solution temperature. To discuss the upper critical solution temperature, we will take the example of phenol and water. So this is phenol and plus water. So the phenol plus water solution have a upper critical solution temperature, and let me draw a graph for this purpose. So this is the axis of temperature in degree centigrade, and this is the percentage weight of phenol increase. So it is 0, 20, 40, 60, 80, and let me write here it is 100. And temperature increases by 20, 40, 60, 80 and 100. So graph is comes like this. So actually this comes between 60 and 80, uppermost point. This is 66 degree centigrade, and there are two layers, and this is tie line at 40. Tie line and its C, tie line and X and Y. So A, B and Z, this is Y. So there are two layers and this is one layer. So what does this graph mean? Suppose if you take this temperature 60 degree, at this temperature 60 degree, at this point there is particular composition of the solution, that is by weight you have to add some amount of phenol. At this temperature, at this point, above this point there are one layer, and below this point there are two layer. It means that if you will increase temperature from here 60 to 61, the solution, the two layers of solution will convert into the single layer. So this solution show the upper critical solution temperature. So phenol water system is a typical example which shows an upper critical solution temperature. Phenol and water are partially miscible at ordinary temperature. When equal volumes phenol and water are mixed, two layers are formed. So I had written here there are two layers. The upper layer is saturated solution of phenol in water, and lower layer is a saturated solution of water in phenol. These two solutions which are in equilibrium with each other are called conjugate solutions. So what are conjugate solutions? The conjugate solutions are those solutions in which liquid solution is present in two layers. In one layer the one is solute and other is solvent, and in second layer same solvent is present as solute, whereas solute is present as solvent. At a given temperature, the composition of two layers is fixed. The addition of small quantity of phenol or water merely changes the volume both layer, but their composition remains the same. So they are explaining just this graph what has been written in theory. So on increase the temperature, the mutual solubility of solution of phenol and water increases. Say I was telling you that at 60 degree it was it, but at 61 degree the solubility increases and the solution changes into one layer. So this temperature at which the two layers become completely miscible is known as upper critical solution temperature. So critical solution temperature for this particular composition is this one. This is the upper critical solution temperature for this composition, and for this composition the upper critical solution is 66 degree Celsius. The critical solution temperature of phenol water system is 66 degree Celsius. The composition corresponds